Hello friends, I am Professor Shubham Shedge from Department of Mathematics, SM Joshi College, Hadapsar. I delivered lecture on a group theory of TYBSc. We are seeing three lectures. In a first lecture, we see the binary operations, commutative binary operations, associative binary operations and its example. In the second lecture, we are seeing groups and its example, and in the last lecture we are seeing abelian groups and its examples and some theorems. In this lecture we are seeing theorems on a groups. So we take first theorem. If G is a group, with a binary operation, star, and if A comma B are elements of G, that is A comma B belongs to G, then A star X is equal to B and Y star A is equal to B has unique solution. That is, here we have a theorem. If G is a group and with binary operation star and A comma B belongs to G, then here then A star X is equal to B and Y star A is equal to B has a unique solution. That is, we have to show that it has a solution and it has a unique solution, that is uniqueness. So first proof. For proving this theorem, let us take, let G be a group and A comma B belongs to G, and we are taking A star X is equal to B has a solution. So A star X is equal to, here A belongs to G, this implies by fourth property A inverse is also belongs to G, because every element in a G has inverse in a G, therefore A inverse belongs to G. By applying pre-multiplying A inverse by both sides, we get A inverse star X is equal to A inverse star B. Therefore, by associativity, we are taking A inverse star A star X is equal to A inverse star B. We know that A inverse star A is equal to identity. This implies E star X is equal to A inverse star B. This implies X is equal to A inverse star B. Therefore, here we are getting a solution of A star X is equal to B. That is, A star X is equal to B has a solution in a G. Now we have to show this solution is unique. So we are taking uniqueness. For showing uniqueness, firstly we are taking, let x1 and x2 are two solutions of A star X is equal to B. That is, x1 and x2 are the solutions of A star X is equal to B. Therefore, x1 satisfies this equation and x2 is also satisfies this equation. This implies A star x1 is equal to B and A star x2 is also equal to B. Here RHS are equal, therefore LHS are also equal. Therefore, we are getting A star x1 is equal to A star x2. This implies by left cancellation law, get cancelled. We getting x1 is x2, x1 is x2, is equal to A inverse star B is a unique solution of the equation A star x is equal to B. म्हणजे आपल्याला सुरुवातीला बघा काय दिलं त्यांनी लेट जी बी ग्रुप दिला, जी हा एक ग्रुप दिला आणि त्यातलं कुठलाही ए बी साठी ए स्टार एक्स इज इक्वल टू बी असेल तर त्याला युनिक सोल्युशन मिळालं पाहिजे असं आपल्याला काय करायचं आहे दाखवायचं आहे. त्यासाठी आपण घेतलं लेट जी बी ए ग्रुप ए कॉमा बी बिलॉंग्स टू जी ए स्टार एक्स इज इक्वल टू बी ला युनिक सोल्युशन असं दाखवायचं. मग आपल्याला माहिती आहे ए जर जी मध्ये असेल तर ए इनवर्स सुद्धा कुठे असतो जी मध्ये असतो. म्हणजे काय झालं इयर ए बिलॉंग्स टू जी इम्प्लाइज ए इनवर्स ऑल्सो बिलॉंग्स टू जी बाय प्री मल्टिप्लाइंग बाय ए इनवर्स वी गेट A inverse star A star x is equal to A inverse star B. By associated we are getting A inverse star A combined, but A inverse star A is equal to identity. Therefore, we are getting x is equal to A inverse star B. Here we have to show that this solution is unique. So we are getting let x1 comma x2 be a solution of B. Two solutions of A star x is equal to B. Therefore, x1 and x2 are also satisfied this equation. Therefore, we are getting A star x1 is equal to B and x star x2 is equal to B. Here RHS is equal, therefore LHS is also equal. Therefore, we are getting A star x1 is equal to A star x2. This implies x1 is equal to x2 is equal to A inverse star B. Is an unique solution of A star x is equal to B. Similarly, we show the solution of y star A is equal to B. It's unique. Second, let G be a group and A comma B belongs to G. And y star A is equal to B has a unique solution. We have to show y star A is equal to B has a unique solution. Here A belongs to G, same as previous A belongs to G implies A inverse also belongs to G. Therefore, by post multiplying this equation by A inverse, we get B star A inverse. This implies y star A inverse is equal to y star A inverse is equal to y star E is equal to, this implies y is equal to B star A inverse. Same as previous example, but in a previous part of theorem we are getting pre-multiplied by A inverse. In this part we are getting post multiplying by A inverse. This is the solution of, that is we have to show that uniqueness. For showing uniqueness we are taking let y1 and y2 are solutions of y star A is equal to B. Solutions of equation y star A is equal to B. This implies y1 and y2 satisfies this equation. Is we are getting y1 star A is equal to B and y2 star A is also equal to B. Here RHS is equal, therefore LHS are also equal. Therefore, we are getting y1 star A is equal to y2 star A. This implies right cancellation of A get cancelled. We are getting y1 is equal to y2. Therefore, the solution of y star A is equal to B is unique. Now we see next term. We have seen next term. Identity. in a group G is unique. Identity in a group G is unique. So take my proof. We have to show identity in a group G is unique. For showing this, we are taking two identities. Let E and E dash be a two identities in a group G. That is, we are taking two identities E and E dash. Here E is identity. This implies X star E is equal to X is equal to E star X for all X belongs to G. For all X belongs to G. This implies X star E is equal to X is equal to E star X for all X belongs to G. This implies, also E dash is identity in a G. Therefore, I forgot the one step. In a particular, we take X. E X is equal to E. This implies, E dash. This implies E dash star E is equal to E star E dash is equal to E dash is equal to E dash. Now, E dash is also identity in a G. This implies X star E dash is equal to E dash star X is equal to X for all X belongs to G. In a particular, we are taking X is equal to E. We get E star E dash is equal to E dash star E is equal to E. Therefore, from equation number 1 and equation number 2, we are get E is equal to E dash. We get E is equal to E dash. There is any problem? Okay. Next, we are getting next term, inverses or inverse in a group G is unique. That is, we have to show that inverse in a group G is unique. So, proof. We are taking, let G be a group and A belongs to G, be any number. And we have to show that this A has unique inverse. This A has unique inverse. For showing unique inverse, we are taking two inverses, A dash and A double dash, and we have to show that A dash is equal to A double dash. So, claim A has unique inverse. So we are taking, let A dash and A double dash are inverses of A, and we have to show that A dash is equal to A double dash. So here A dash is inverse of A, by definition of inverse, A star A dash is equal to A dash star A is equal to identity. Also A double dash is an inverse of A double dash is also inverse of A. Therefore, we are getting A star A double dash is equal to A double dash star A is equal to identity. Here equation number 1 and equation number 2. From equation 1 and 2, we are getting A star A dash is equal to A star A double dash. A star A dash is equal to A star A double dash. By left cancellation law, we get A get cancelled. We get A dash is equal to A double dash. A dash is equal to A double dash. That is inverse of A is unique. Inverse of A is unique. And A being an arbitrary element, so inverse of any element in a group G is unique. That is inverse in a group G is unique. Hence the proof. Next. Next, corollary. Corollary. In a group G, A star B inverse is equal to B inverse star A inverse. That is, we have to show that A star B inverse is equal to B inverse star A inverse. For showing this, we have to show that inverse of A star B is B inverse star A inverse. So, we know that if B is inverse of A, then A star B is equal to B star A is equal to identity, and it is denoted by A inverse is equal to. म्हणजे आपल्याला माहित आहे, we know that जर B हा A चा इनवर्स असेल तर तो कुठली कंडिशन सॅटिस्फाय करतो, A स्टार B is equal to B star A is equal to identity, and it is denoted by A inverse is equal to B. Here, now consider A star B inverse star A. We are considering these elements A star B inverse star A inverse. By associativity, we are getting A star B inverse star A. By applying associativity, we know that B star B inverse is equal to identity. Therefore, we are getting A star E star A inverse. A star E is equal to A. So, A star A inverse is equal to identity. Also, B inverse star A. Also, B inverse star A inverse star B star A is equal to. By applying associativity, by applying associativity, we are getting B inverse star A inverse star A star B is equal to A inverse star A is equal to identity. So we get B inverse star E star B is equal to B inverse star B is equal to identity. Therefore, we know that by property 4, if A star B is equal to A star B is equal to B star A is equal to identity, then B is an inverse of A. Therefore here B inverse star A inverse is an inverse element of A star B. Therefore B inverse star A inverse is an inverse element of A star B. Therefore it is denoted by A star B. Its inverse is equal to B inverse star A. That is, inverse of product is reverse product of its inverses. Inverse of product is an reverse product of its inverses. Okay. Now next example. Show that in every group G with identity E and x star x is equal to identity is abelian group for x belongs to G. म्हणजे काय बघा, in a group G with identity E and x star x is equal to identity is an abelian group. आपल्याला काय करायचं तर हा abelian group दाखवायचा जो G ग्रुप असेल तो. So for showing this example, we will get solution. For solve this example, here let G be a group, here G be a group and E be an identity of G with x star x is identity for all x belongs to G. X star is x is equal to identity for all x belongs to G. Now we see that A star B is equal to identity, then A inverse is equal to B. So here x inverse is also x. X inverse is also x. Now getting A star B is also element of G. If A comma B belongs to G, then let AB belongs to G. Let AB belongs to G and G is a group, so A star B is also belongs to G. Therefore, A star B satisfying this condition, A star B inverse is equal to A star B, because here x inverse is equal to x for all x belongs to G. Therefore, we are getting A star B inverse is equal to A star B. But by previous theorem or corollary, A star B inverse is equal to B inverse star A inverse. Here D belongs to G, therefore B satisfies this property. We are getting B inverse is equal to B and A inverse is equal to A. Therefore, A star B inverse is equal to B star A. Here LHS is equal, so RHS is also equal. Therefore, we get A star B is equal to B star A for A comma B belongs. Therefore, G is abelian. Therefore, star is commutative. Star is commutative. Therefore, G is abelian. is म्हणजे इथे काय केलं बघा, जी ही हा ग्रुप घेतला आणि ही आयडेंटिटी दिलेली आहे आणि एक्स स्टार एक्स इज इक्वल टू आयडेंटिटी म्हणजे एक्सचा इनव्हर्स कोण आहे तर एक्सच आहे सगळ्या जी मधल्या एलिमेंटसाठी. मग ए स्टार बीचा इनव्हर्स सुद्धा काय असणार आहे ए स्टार बीच असणार आहे म्हणून काय येतं ए स्टार बी इनव्हर्स इज इक्वल टू ए स्टार बी. बट बाय प्रिव्हियस कलर ए स्टार बीचा इनव्हर्स काय असतो आपला बी इनव्हर्स स्टार ए इनव्हर्स. बी हा जी मधला एलिमेंट आहे तर बी इनव्हर्स इज इक्वल टू काय येणार आहे बीच येणार आहे कोणते पुटअप केलं आणि ए इनव्हर्स सुद्धा काय येणार आहे ए येणार आहे म्हणून ए स्टार बीचा इनव्हर्स इज इक्वल टू काय आपल्याला बी स्टार A. Here LHS are equal, therefore RHS are also equal, therefore we are getting A star B is equal to B star A for all A comma B belongs to G, therefore star is completed, therefore G is an abelian group. Next we have a definition idempotent element. An element X belongs to G is said to be idempotent if an element X belongs to G is said to be idempotent if X square is equal to X. जी मधल्या एखाद्या एलिमेंटला तुम्ही आयडेंपोटेंट कधी म्हणाल तर एक्स स्क्वेअर इज इक्वल टू काय आला पाहिजे एक्स आला पाहिजे तर तो एलिमेंट काय असतो आयडेंपोटेंट. नेक्स्ट एक्झाम्पल शो दॅट ग्रुप G has exactly one idempotent element. Exactly one idempotent element. Solve. जो ग्रुप जी मध्ये फक्त एकच आयडेंपोटेंट एलिमेंट मिळतो असं आपल्याला काय करायचं आहे दाखवायचं. तर लेट ए बिलॉंग्स टू जी अँड ए स्क्वेअर इज इक्वल टू ए. आपल्याला किती एलिमेंट आहेत म्हणजे ए च्या किती व्हॅल्यूज येऊ शकतात. ए स्क्वेअर इज इक्वल टू ए म्हणजेच काय ए स्टार ए इज इक्वल टू ए. बाय लेफ्ट कॅन्सलेशन लॉ वी गेट A get cancelled, that is here we are getting A is equal to E. A is equal to E. This implies A is identity. In a previous theorem we are seeing identity is unique in a group, so A is identity and identity is unique, therefore this implies idempotent element its identity and identity is unique. It implies idempotent elements in G, group G is unique, that is exactly one element is idempotent. Exactly one element is idempotent. Thank you for watching this video. Thank you very much. For any query about these examples or theorem, please say it in comment box. Thank you.